I will present some old and more recent data about conditional reasoning in children and adolescents within the general framework of the mental model theory as a good theoretical framework for understanding that. I will begin by presenting some generalities about the importance of psychology of deduction and the two former ways to theorize this production of deduction, which is mental logic and mental model theory. And I will present some data about development of mental models and the new way of understanding reasoning today, which is the new paradigm psychology based on probabilities. And I will propose some modified mental model theory of conditional reasoning to account for the main data discovered by this new trend. And I will present some findings for testing the theory with a task known as the true stable task and another task known as the probability task. And I will ask the difficult question of if there are developmental stages in the development of reasoning, and the answer is no. So you can go back, it's finished. So let me begin by psychology of deduction. It's an old problem of the nature of deductive reasoning because human beings are rational or like to be rational, and rationality is often seen as the ability to make deductions because they yield consequence of rules, laws, theorems, and so on. And then underpins scientific reasoning. So deduction is central for human cognition. And the two questions, traditional questions, are what are the cognitive foundations of deductive reasoning, and does deduction depend on logic? And a first response was the mental logic. So mental logic was the idea that there are logical rules in human mind, and these rules are triggered by reading or hearing some premises. And for example, somebody presented with a sentence like, if the box is red, it contains pencils. It was assumed by these theories that people would, oh, sorry, it's the other one. And this sentence would activate the logical rule if P then Q, and if people were presented with the second premise of the form of P, the box is red, the idea was that this rule is triggered and produces the conclusion it contains pencils. And it was imagined by Brain or Lance Jeffries that these kind of rules are probably innate and govern our deductions and reasoning. But it doesn't work very well because it's known that conventional logic is monotonic, which means that once a deduction has been reached, it cannot be withdrawn by anything else. And in fact, people withdraw many often conclusions because when they are presented with new facts, they abandon their first conclusion. For example, in this example, when we know that Mark manages to illegally download new books, it's quite sure that it will not buy this book. And also, conditionals often do not correspond to any logical connective. For example, if you like Westerns, Rio Bravo is on TV tonight, it's clear that the fact that Rio Bravo is on TV tonight doesn't depend on the fact that you like Westerns or not. So this is not an if-then that can be translated in logical form. And mental logic applies to logical forms, in fact. The idea was that these rules were syntactic in nature, and nobody knows how logical forms could be extracted from sentences to activate these rules. So the following idea proposed by Johnson Laird was that people reason not with logical rules, but from mental models that they construct. And the idea is that a mental model is just a representation of a possibility when the sentence is true. For example, if the box is red, it contains pencils, people would represent a red box and pencils, and this would be the mental model corresponding to this sentence. And where they are informed that, and probably they are aware that there are other possibilities, but these possibilities remain implicit in the first time. And when people know that that the box is red, this matches this first model, and they can produce a conclusion it contains pencils. If the box is blue, this doesn't match this first model, and so the theory assumes that people can construct additional models. For example, a blue box with no pencils inside, and in this case, the conclusion could be that it doesn't contain pencils. But people can go further and construct a third model, which is still compatible with the first sentence, where the box is blue, but it contains pencils. That's possible. And in this case, there is no conclusion. This is the idea of the mental model theory. And it can be summarized in this way. First, people construct an initial model with an explicit representation of the co-occurrence of P and Q and an additional implicit model. And this implicit model can be made explicit by a process known as fleshing out. And here is the construction of a second model resulting in a biconditional interpretation in which the red box contains pencils and those boxes that are not red do not contain pencils. And in a better and more elaborated interpretation, people would be able to construct a third model. And in this case, they reach a conditional interpretation, which is the complete and correct interpretation of the first sentence. Okay? This can be summarized as one explicit model for the initial model, two models with one which is fleshed out for biconditional interpretations, and conditional interpretation with two fleshed out models added to the first representation. And this could have interesting developmental extensions because it could be imagined that with age, we could imagine in the first place that children should be able first to construct one, and then two, and then three models. And we could have a developmental in terms of an increasing number of models that can be constructed. And this is the hypothesis we tested first with the idea that if children are presented with sentences of the form, if the box is red, then it contains pencils, and if they are asked to identify those cases that are incompatible with the conditional, we should have three different types of responses. Because those who are conjunctive in nature, that is, understanding if P and Q as the conjunction of P and Q, that's all, and should identify the three other cases as incompatible with the rule. Those who adopt a biconditional reading should just identify these two cases as incompatible with the rule, and those probably older that adopt a conditional reading should identify the sole P and not Q case as incompatible with the conditional. And we presented this kind of task, which is very simple. For example, the rule is if you put on a white shirt, then you put on a blue trousers, and children are asked to identify those cases where the rule is not obeyed. And we observe the following results. Third graders mainly adopt a conjunctive interpretation of the biconditional. That is, they identify three different cases as incompatible with the rule. And then sixth graders adopt the three interpretations approximately with the same frequency. And older adolescents favor a conditional interpretation. And so we have a nice developmental trend from a conjunctive to a conditional interpretation with biconditional interpretations constituting something like a middle term. And we also tested the relationship between this kind of interpretation and working memory capacity, because the idea was that the number of models that children can construct depend on their working memory capacity. And we used a slightly different task, which is not a task in which people are asked to identify those cases that are incompatible with conditional, but they are asked to produce admissible cases. So they are given material like this, and they have to produce as many cases as possible corresponding to, if you put on a white shirt, then you put on a blue trousers. And we expect that, of course, younger children will only produce one possibility, which is this one, and older children should produce two different cases, which is this one and this one. And finally, some children should even consider that it's possible to have a gray shirt with blue trousers, which is not incompatible with the rule. And at the same time, children and adolescents were presented with a counting span task in which children have to count the dots in successive chords, and at the end of the series, they have to recall the totals, which is a very difficult task. And these are the results. We classified population in low, medium, and high working memory capacity, and these are their main and preferred interpretation of the conditional, and we can see that low span individuals mainly adopted a conjunctive reading, and high span individuals adopted a conditional reading, with biconditional reading as my middle term, and the correlation between the number of different possibilities constructed and working memory span was 0.65, which is not so bad. We also tested, slightly before Phil Johnson learned himself, the concept of modulation. Modulation is the main concept of the mental model theory, which assumes that the construction of mental models can be modulated by semantic or pragmatic knowledge, and in such a way that it can facilitate the construction of some models and hinders the construction of other models. For example, we discovered a strange effect due to binary terms. A binary term is a term that has only one possible alternative. For example, if the pupil is a girl, the other only possible alternative is boy. Okay, there are just two possibilities. And if the pupil is a girl, then she wears glasses. The other possibilities is that boys don't. And so this leads to what we call a complete representation, in which every case here is matched with one case here. And these binary terms should block the construction of not PQ cases of the form a boy wearing glasses. And so the prediction that binary terms should induce biconditional interpretations. And this is what was observed. This is the first slide before with non-binary terms. So you have the traditional developmental trend from conjunctive to conditional interpretations. And this is the responses with binary terms. And we can see that the developmental trend has disappeared, and everybody produces the predicted by conditional interpretation. So these were quite well, but recently, many authors judged that most probably the mental logic and the mental model theory are wrong, because people do not reason in this way, and they most probably reason using probabilities. And the idea is that any of our deductions, all our deductions, are based on probabilities and calculation on probabilities. And these authors named their theories the new paradigm psychology of reasoning. And you have here some of these authors. And there are two main ideas. The first is that traditional theories of reasoning, like mental logic or mental models, are rooted on formal logic. And the idea is that reasoning is a process of deduction, that's true. And these theories are based on binary distinctions like truth, falsity, and so on. And they reject these ideas, assuming that reasoning is a matter of degrees of beliefs, utility, subjective probability, and most probably reasoning is just probability judgments and not deduction from truth or falsity. And they are quite assertive. For example, here you have a quote by El-Quayyam and others, assuming that studying probability judgment will tell us more about the psychology of reasoning than trying to figure out how far people confront binary extensional logic. So thank you for this effort. And these theories are mainly based on conditional, because the main assumptions concerns conditional reasoning. And the first idea is that the meaning of conditional is going to be probabilistic in nature, suppositional, based on what they call the Ramsey test. The Ramsey test consists when you assess an if P then Q sentence to add P to your stock of knowledge, to your beliefs, and on this basis to assess the likelihood of Q, disregarding not P cases. For example, if you want to assess the validity or the plausibility of a conditional like if Queen Elizabeth dies, Charles will become king, and you imagine that Elizabeth is dead. Sorry, Valerie, for that. And
you want to keep not P in that case, don't you?
And you try to imagine the probability that Charles becomes king, and probably very high, of course. And people's degree of belief on a conditional should equate, in this case, the conditional probability, which is the probability of if P then Q is just the probability of Q given P. Okay? And this is very important for this theoretical trend. It is such important that they call this equality the equation, okay, which is the basis of most of the human reasoning, according to the new paradigm psychology of reasoning. There are two main empirical evidence for this theory. The first is that when people are asked to assess the truth value of a conditional, they adopt what we call a defective or a definitive truth table. Definitive is the name of the guy who first described this kind of truth table, in which when assessing the truth value of a conditional, the PQ case makes the conditional true. The P not Q case make it false, of course. But the two not P cases leave the truth value of the conditional indeterminate. This is different from the traditional view of logic, in which the conditional has a material implication truth table, in which the conditional is true for these three cases and just false for P not Q case. So the idea is that not P cases are considered as irrelevant for truth table, for truth value. And it's true that when people are asked to judge the truth value of a conditional, very often they adopt this kind of definitive truth table. And the other evidence is the probability task. When people are asked to assess the probability of if P's and Q sentences, very often they adopt the conditional probability of Q given P. And this has been demonstrated by Evans and Lee and others, and Oberauer and Willem and so on. Okay. And these two facts are taken as evidence against the mental model theory because according to the new paradigm theoreticians, the mental model theory should predict not a definitive truth table, but the material implication truth table in which the three cases constructed should be judged as making the sentence true and just P not Q as making it false, and there should be no response of irrelevance. And when asked to assess the probability of a conditional, people should give a response in which they should add the probabilities of the three cases that are represented in the conditional interpretation, as I showed before. And this never occurs. Nobody gives this kind of response, in fact. So we were confronted with a big problem because the traditional mental model theory doesn't make the job and doesn't account for this kind of phenomenon, which is why we proposed a modified mental model theory of conditional reasoning. Okay. And in this modified mental model theory, we assume first that reasoning is a dual process that governs the construction of mental models. A first type of process, heuristic process based on a system one cognitive system, named system one if you want, which is implicit, automatic, fast, not limited by working memory capacity. These heuristic processes would produce some initial representation, very simple, default initial representation. And after the production of this initial representation, analytic processes pertaining to some system 2 could flesh out the initial representation and construct additional model. But the intervention of these analytic processes is just optional. And sometimes, and in most of the cases, people should only reason from their initial model. This simple idea makes that the epistemic status of the different models constructed should vary depending on the nature of the processes governing their construction. Because for naive reasoners, the initial model should capture what makes the sentence true, because these initial models come spontaneously to mind without any reflection, and they appear as the real meaning of the sentence. And so when confronted with cases that match this initial model, people should consider that the sentence is true. But when confronted with cases that match additional models constructed through fleshing out, people should consider that the truth value of the sentence remains indeterminate. It's just when presented with cases that do not match any of the models constructed that they should deem the conditional false. Let's take an example. Imagine that people are asked to judge the truth value of a sentence, like if there is an A, then there is a 5. And we can imagine that people construct an initial model of the form A5. Okay. When presented with a case that matches this representation, of course, people should probably think that the sentence is true, because...
So this is the Wason task, where the 5 is on the other side.
Yeah, exactly. No. These are true, they're two calls. Okay. And imagine now that people still maintain this initial model and they are presented with the case B3, and this doesn't match the initial model. So the sentence is not true, in fact, not entirely true, but if there is some fleshing out, people can observe that B and 3 matches this model here. And in this case, the sentence is not absolutely true, but it's not false. So it's not either true nor false. So it's kind of indeterminate truth value. By contrast, if they are presented with A and 3, this doesn't match the initial model, and it doesn't match none of the constructed model by the following, and so sentence is false. Okay? And this makes very simple developmental predictions, because imagine that children and adolescents are presented with the truth value task. So they are given a sentence, a conditional sentence of the form if P then Q, and they are presented with the 4 different logical cases. And for each of these cases, they have to say if the sentence is true or false, or if one cannot know if it's true or false. Okay? Children who adopt a conjunctive interpretation with just one model should consider that the sentence is true for this model and false for all the 3 other cases, because they are not represented at all. Children who adopt a biconditional reading with adding not P not Q model by fleshing out should consider, of course, the sentence true for PQ, false for the cases that are not represented in their representation, but they should consider the conditional as indeterminate for the case that matches the models they have fleshed out. Okay? And here we should have, for people adopting a conditional interpretation, true for PQ, false for P not Q, and the indeterminate response for the 2 cases that match the 2 models with not P that have been constructed by fleshing out. This is the definity table, truth table, shown above, the defective truth table produced by adults. And what this theory predicts is that this definity table should be preceded developmentally by 2 different response levels. And the hypotheses are quite simple, because we assume that the heuristic system does not develop so much during childhood and adolescence. And so for a given type of conditional, initial model should remain largely unchanged through development. And the case making the conditional truth should thus remain stable across age, because models pertaining to the initial model make the conditional true. The analytic system, which strongly develop with age, should lead to a rate of indeterminate responses increasing with age strongly, because the analytic system constructs the models through fleshing out, and the case that match the fleshing out models lead to the indeterminate response. And finally, the analytic system is influenced by the heuristic system in many of the dual processes theories, and this should be the source of the modulation effects described above.
Pierre, is it okay to ask a question about that?
Yeah.
They're supposed to be, I mean, in some conceptions they were modular, though. So the heuristic is walled off from the analytic. So they're not supposed to interact in many models.
Yeah. In this,
is it really analytic? It's being influenced by the heuristic system, right?
In this idea, the idea is that the heuristic system provides the representations on which the analytic system works. Okay. So the idea is that the heuristic system is responsible for the production of the initial representation, and analytic systems work on this initial representation.
So then it's not really abstract.
Sorry?
Then the analytical system cannot be abstract, because it's going to be influenced by knowledge.
It can be abstract in the sense that you can, for example, imagine that there are some abstract rules that can apply to different contents depending on the nature of the representation constructed from the heuristic system. So the output of the analytic system can be influenced by the heuristic system without supposing that the analytic system doesn't contain, for example, absolutely abstract rules. You can have abstract rules with an output depending on the input, okay? Maybe.
Is there, yeah, it's. Could be.
Could be. We tested the theory with a truth testing task. The task is the following. Children are presented with a sentence, like if the circle is red, then the star is blue. And then they are presented with the content of a box, which appears on screen. And they have to say, for this case, if the sentence is true, false, or one cannot know if it's true or false. In this case, it's false, okay? Because if the circle is red, the star is blue, but it's not. So here, you have to tick this box. And of course, we expect that we expect to find these three kinds of response: conjunctive, defective, biconditional, in which not P nor Q cases leave the truth value of the conditional indeterminate, and here two cases leaving the conditional truth value indeterminate. And this is mainly what you observe. Third graders mainly produced conjunctive responses. Adults mainly produce defective conditional responses. This is a defective truth table described by the new paradigm. And graders, 6th and 9th graders mainly produce biconditional responses, with 9 graders beginning to produce conditional response in this case. And we tested the effect of binary terms in this task because binary terms should lead to just the construction of the not P, not Q model through fleshing out. So what the theory predicts is that in a truth table task, people should produce defective biconditional patterns. And this is what we observed with binary terms in both the antecedent and the consequence of the conditional. Many people produce biconditional responses. Younger participants remain unaffected by the manipulation of binarity, because, most probably because if they produce conjunctive responses, they do not flesh out their model. And so they should remain unaffected by the manipulations of the facility of fleshing out. And the other finding is that there is a strongly reduced developmental difference. And we also tested promises and threats because these are interesting sentences like, if you mow the lawn, then I'll give you €5. Even Newstead and colleagues in 1997 demonstrated that this kind of sentence has a strange truth table in which there are two cases that are judged to make the conditional true, which are the lawn is mown and the child receives €5, and the lawn is not mown and it receives nothing. These two cases make the conditional true, and the two other cases make it false. And this makes sense because if you promise that if you mow the lawn, then I'll give you €5, and the child mows the lawn, you have to give him the €5. And if you don't, you are a liar. And of course, a child who doesn't mow the lawn should receive nothing. Because if it receives something, there is something wrong. And so this is why this truth table is very simple with two cases true and two cases false. And this makes sense because we assume that heuristic processes in this case deliver a two-model initial representation, because correctly understanding this kind of promise is understanding that if you mow the lawn, you will give your €5. But if you don't, I don't give you anything because I want to have my loan mown and you want €5. So it's a good deal. And there is no fleshing out at all in this case because there are just an initial model with 2 representations and the 2 other cases are not compatible with the conditional. So there should be no developmental at all because there is no fleshing out. And this is what happens. These are the strange equivalence truth tables, and they are produced for promises and for threats, even by 3rd graders, because even 3rd graders very often correctly understand promises and threats, fortunately. And we also tested, that's true. And it's very effective because when you work on reasoning, you can ask your children to make things like this, and you say, and you know, the mental theory predicts that you should understand that, and it works. We also tested the theory with the probability task. The probability task is a very difficult task. Imagine that you are presented with cards like this of the 4 different logical cases, black and white cards with squares or circles, and you are asked, how likely is the following statement to be true of a card drawn at random from the pack? If the card is black, then there is a square printed on it. It's a strange task. It's not random if, for example, Klaus Oberauer thought about this kind of task, because it's very complex, in fact. And what people do in this case is to responding in this way. As the new paradigm predicts, they disregard not P cases that are not taken into account, and they just assess the probability of finding a square in black cards, okay? And the probability is 2/3 in this case, okay? And about 60% of adults respond in this way. And it has been even demonstrated that, as you will see, many people, even adults, do not respond in this way in the first place. But if you present a 2nd and a 3rd and a 4th and a 5th trial, many of those people move to this kind of response at the end, surprisingly. Okay? The question is that very often, by the past, when people presented a theory of reasoning, one of the main tests for this theory was the developmental test. For example, in the mental logic approach, authors assume that our mind is endowed with logical rules, and the best proof of that was to demonstrate that these rules were already present and efficient even in children, and even in young children aged 5, 4. And by the way, it's true that, for example, young children are able to produce modus ponens, which is the rule I show in the first place for the conditional if P is in Q and P, then Q. And in the same way, we have seen that, for example, the minimal representation that is hypothesized by the mental model theories, the initial model PQ, is already present even in young children. So I reason that what we need with the new paradigm theories is some developmental test of a possible presence of the equation, the conditional probability, even not in young children, of course, but at least in adolescents, for example. At the beginning of adolescence, it should be not so bad. And so if it's true that conditionals are probabilistic in nature, and if it's true that the equation is the core meaning of the conditional, the equation should exhibit some pervasiveness through development, types of conditionals and contents and so on. And we tested this using our own model with a very simple prediction, which is that how people assess the probability of a conditional, probably in calculating the ratio between the cases that make the rule true and those that are relevant for the truth value of the rule. And in the same way, the probability that the conditional is false should correspond to the ratio between the number of cases that make the conditional false divided by the number of cases that are relevant for truth value. But we know that there is an age-related evolution of the relevant cases, because remember that irrelevant cases correspond to those that match the models constructed through fleshing out, and fleshing out strongly develop with age. So the number of relevant cases vary from one age to another, and the probability of the conditional should evolve with age in a predictable way. And in this way, imagine, for example, a children adopting a conjunctive probability in this task, and he has to assess the probability that if the card is black, then there is a square printed on it. That's simple because there are just two cases that make the conditional true. So the probability that the statement is true is 2 out of 8, because all the cases are relevant here, because the other cases make the conditional false in the conjunctive probability reading. Okay? So they should respond that the probability is 2 out of 8, which is different from somebody adopting a defective biconditional probability, because defective biconditional reading leads to, of course, assuming that there are still two cases that make the conditional true, but these cases are irrelevant because not P not Q has been produced by fleshing out in the biconditional reading. And so the number of relevant cases is not 8, but 6. And people who respond 2 out of 6 reflect the defective biconditional reading. And those that adopt a defective conditional probability should respond, of course, still 2 out of, but out of 3, because all the not P cases are irrelevant now. And so this is the equation described by the new paradigm. And so we presented this very difficult task to 6th, 9th graders and adults. And while there is no third graders, we try to do that. But they never grasp the task. Right? Because assess the probability of something that is not sure in the first place, because the probability of if, they were reluctant. And this is the same task as presented in adults. And these are the results. Here you have the conjunctive responses, mainly in grade 6. 9th graders adopted the 3 ways of reading, and adults produced 60% of conditional reading. This is the equation. And 40% of them were conjunctive in responses. And this is not an isolated finding, because this was also observed in the first studies both by Evans and by Klaus Oberauer. And so we can see that as the equation is, for example, absolutely absent in 6th graders and rarely produced in 9th graders. And we also found, we looked for the occurrence of the equation through contents and context, for example, using binary terms. Remember that binary terms elicit very often a defective biconditional reading. So in the probability tasks, they should elicit defective biconditional responses. And just non-binary terms should elicit the equation responses just in adults. And this is what we observed. This is the responses for the probability task with binary terms, and the responses corresponding to the equations are rare. And very often people produce defective biconditional readings, and the probability that goes with this kind of interpretation. And we also try with the promises and threats that elicit the equivalence reading. And in this case, people should consider that what is the probability of, if you mow the lawn, then I will give you €5 for a card drawn at random from the pack. And this should be 4, because there are 4 cases that make the conditional true in this case. Out of 8, because these are making the conditional false, remember. Okay? And this is exactly what happens for promises and for threats. 6th graders, 9th graders, and adults very often produce an equivalence reading, and the corresponding equivalence response is a probability task. And
Nobody's a communist.
no.
They just are.
By the past, we had communists in France, but no longer now. Yeah. Maybe it's too late for this kind of experiment. You're right, these are Swiss people. So this is the reason, probably. And the last question is, are the 3 levels developmental stages? Because we have seen that in all the tasks, you have always the same developmental trend from conjunctive to biconditional and then conditional interpretation. And we could imagine that these 3 levels constitute 3 developmental stages à la Piaget, if you want. But it's not at all the case. These are the 3 tasks we have seen today. The possibility task, tasks in which people have just to say if this case is compatible with a rule, which is considered as true, okay? Or children are asked to produce cases that are compatible with the rule. This is the truth value task. This is a task in the reverse direction. People are given a case, and they have to judge the truth value of the conditional, which is, in the mental model theory, a more difficult task. Because remember that mental models are representation of possible cases. So thinking about possibilities is a natural way of thinking and reasoning about truth values is something like a meta processing and a meta reasoning, and it should be more difficult. And finally, you have the probability task here, which is even more difficult. And you see that the number, for example, the number of biconditional responses in 3rd graders is lower for the truth values than the possibilities task, and these are the other responses reflecting some misunderstanding of the task, and this is their response in the probability. They are not able to do that. And this is clearer for 6th graders. 6th graders adopt a biconditional reading with the easiest possibility task. But you can see that they move to the primitive conjunctive interpretation when we move to more difficult tasks. And this is also the case for 9th graders who are conditional with the simplest task, but just biconditional with the truth value task. And for the probability task, you can even see a lot of conjunctive response. And this is even true for adults. you can see that the number of conditional responses decreases as the difficulty of the task increases. So these three levels are probably not developmental stages. They are most probably the reflection of a capacity to produce more or less complex representations interacting with the inherent difficulty of the task.
And you're still getting 40% conjunctive in adults with probability tests.
Yeah, this is a kind of mystery, but I think we have an explanation.
But people get it. I mean, everybody gets it.
I think we have an explanation because you can see that the conjunctive interpretation is almost never observed in the other tasks. Most probably this is not a real conjunctive reading. And we have observed in another experiment, but I don't have the result in these slides. When adults are presented with a truth value task with only two possibilities. So they are given cases, and for each of these cases, they have to say if the sentence is true or false, but they have just two possibilities, which is true and false. You remove the possibility to say, oh, it's indeterminate, irrelevant. In this case, it appears that you have approximately the same pattern of responses. And with 60% of adults responding in a way which is, in this case, the material implication, the sentence is true for PQ, not PQ, not P, not Q, and it's just false for P, not Q. But you have 40% of these adults who judge that the sentence is true for PQ and false for the both not P cases and P not Q case. And I think that these guys here probably understand that their task in the probability task is to say if the sentence is true or false with no possible alternative. And in this case, they adopt this kind of truth table for calculating probability. I think this is the solution because I just mentioned the responses for the probability of true, but we have also the same results for the probability of false. And in this case, when people are asked to say what is the probability that the conditional is false, they respond in a conjunctive way too. And they assume that the three cases that are different from PQ make the conditional false, which never occurs when, for example, they are thinking about possibilities. All the adults, without any exception, assume that not P cases are compatible with the conditional. But when asked if these cases make the conditional true or false, sometimes they prefer to say that it makes false. It's kind of paradox, but I think it can be understood in some ways. It's a very difficult task, in fact. And at the beginning, I didn't grasp the task, in fact. When I read the first time, what is the probability of conditional? And with additional thought, I said, okay, something like that. Well, some conclusion. So you have seen that conditional reasoning strongly evolves with age, with 3 developmental levels in every task that are not developmental stages. Most probably this is due to the fact that people can construct increasingly complex representations depending on working memory capacity, but performance is also a function of the cognitive demand of the task. And even if you are able to produce a conditional interpretation in one task, This doesn't mean that you will be able, for example, to produce a response in the probability task corresponding to this conditional interpretation. And at least from the study with children, there is no need to assume a probabilistic meaning of the conditional because a modified mental model theory can account for the adult data that led to promoting this kind of theories. And it also predicts developmental findings that cannot be predicted and explained by the probabilistic approach of conditional. That's all. Thank you.